Hello, in this video we will be deriving 60-30 degree right triangle and evaluating trigonometric functions of 60 degrees and 30 degrees. Deriving 60-30 degrees right triangle begins with sketching an equilateral triangle, which means all sides and angles are congruent. So this would immediately create 60 degrees all around, 60, 60, 60, because it's the only way of splitting 180 degrees equally. So 180 divided by 3, we get 60 degrees all around. The next thing is to decide the measure of the side you will be working with. It does not matter, you can say 1, 1, 1 all around. So to get 60-30 degree right triangle, we will be cutting this sketch in half. One of the 60 degrees will be divided by 2 and we will have our 30 degrees reference angle. So the decision we have to make is what to label the sides, and the best possible number would be to give the measure of 2, because 2 divided by 2 will give us nice whole number 1. In equilateral triangle, it will mean that all sides are labeled 2. So now we have a sketch of 60, 60, 60 degrees angles and all sides are equal to 2. The process of creating a 60-30 degrees right triangle is dropping a perpendicular from one of the angles onto the opposite side. So this gives us the right angle. In an isosceles triangle, if you drop a perpendicular, it also becomes the height, and it divides the opposite side into 2 equal pieces. So we would divide this side by 2, which would mean that this side would be equal to 1. It does not matter which side you keep. This perpendicular line also divides 60 degrees into 2 equal pieces, which would leave us with a 30 degrees to be in this angle. And then this side usually gets erased. So I'm going to zoom in on this sketch over here. Now we would have 60 degrees would be unchanged over here. Hypotenuse will be equal to 2 because this side did not change. We have this corner being right angle, 90 degrees. The adjacent side to 60 degrees equal to 1 because it was half of 2. The angle opposite to 60 degrees will be 30 degrees because it was half of 60. So all we need to do now is to find the measure of the side adjacent to 30 degrees, and we can do that by using Pythagorean theorem, which is c squared equals to a squared plus b squared. So the measure of the hypotenuse is equal to 2, so we get 2 to the second equals to measure of one side, which is 1 to the second power, plus measure of the other side, which we don't know, so let's have it as b squared. It does not matter which leg you label as a or b for Pythagorean theorem, as long as you identify the hypotenuse properly. On the next step, we have 2 to the second is 4 equals to 1 to the second is 1 plus b to the second. In order to solve for b squared, we need to minus 1 on both sides, and we get 4 minus 1 is equal to 3 equals to 1 minus 1 is 0. So we have b to the second on the left side. Square will cancel out with a square root, so I'm going to square root b squared. Whatever I do to one side, same thing to the other side. Square and the square root will cancel, and we will get b is equal to square root of 3. This side is equal to square root of 3. In this example, we will be evaluating trigonometric functions of 30 degrees. So once you have 60-30 degrees triangle derived, 30 degrees is labeled over here adjacent to radical 3 side. Once you identify location of 30 degrees, we can start setting up trigonometric ratios. So we have sine of 30 degrees is equal to, sine is the ratio of opposite sides, and the opposite side from 30 degrees is 1, divided by hypotenuse. In this example, it's equal to 2. Once we know the ratio of sine, we know the ratio of cosecant of 30 degrees, which is a reciprocal of 1/2, which is 2 out of 1. So when sine of 30 degrees is equal to 1/2, cosecant of 30 degrees is equal to 2. Cosine of 30 degrees is equal to measure of the adjacent side, and adjacent side to 30 degrees is radical 3, divided by hypotenuse, which is equal to 2. Cosine of 30 degrees is radical 3 out of 2. Once we know cosine, we can set up secant of 30 degrees will be reciprocal of radical 3 out of 2, so it will be 2 out of radical 3. We need to rationalize 2 out of radical 3. Square root in denominator will cancel out with the second power, so we need one more factor of radical 3. Whatever we multiply denominator by, we need to multiply numerator by the same thing, so radical 3 times 2. So we get secant of 30 degrees is equal to 2 radical 3 out of square root of 3 to the second power. Second power and square root will cancel out, and we get secant of 30 degrees is equal to 2 radical 3 out of 3. Tangent of 30 degrees is equal to a ratio of opposite side, and opposite side to 30 is still 1, out of measure of the adjacent side, which is radical 3. Once we have tangent of 30 degrees, we can set up cotangent of 30 degrees, which will be a reciprocal of 1 out of radical 3, which is radical 3 out of 1. Cotangent of 30 degrees is equal to radical 3, and we need to rationalize the ratio for tangent of 30 degrees. Square root will cancel out with a square, so multiplying radical 3 by radical 3 will give us a square in denominator. Whatever we multiply denominator by, we need to multiply numerator by the same thing, because square root of 3 out of square root of 3 is 1, so we are multiplying this thing by 1. So we get tangent of 30 degrees is equal to 1 times radical 3, we have a square root of 3 in numerator, out of, you can also rewrite this denominator as radical of 3 times 3, 3 to the second, cancel out square root and a square. So we get tangent of 30 degrees is equal to radical 3 out of 3. In this example, we will be evaluating trigonometric functions of 60 degrees. Once you have reference triangle for 60-30 degrees figured out, our reference angle is right here. Adjacent side is 1. Once you know the location of your reference angle, you can set up the trigonometric functions. Sine of 60 degrees is equal to, sine is the ratio of opposite side, and opposite to 60 degrees we have radical 3 divided by hypotenuse, in this case it's 2. So sine of 60 degrees is radical 3 out of 2. Once we know sine, we can figure out the cosecant ratio of 60 degrees. It is reciprocal function of radical 3 out of 2, so it will be 2 out of radical 3. We need to rationalize this, so we have square root of 3 in denominator, Square root will cancel out with the square, so let's multiply denominator by another factor of radical 3. Whatever we do to denominator, let's do the same thing to numerator. Cosecant of 60 degrees is equal to 2 radical 3 numerator out of radical 3 to the second in denominator. Square root and a square will cancel, and we get cosecant of 60 degrees is equal to 2 radical 3 out of 3. Cosine of 60 degrees is the ratio of adjacent side, in this case it's 1, to the hypotenuse, which is 2. So cosine of 60 degrees is 1/2. Once we have cosine, we can set up secant of 60 degrees, which will be a reciprocal of 1/2, which is 2 out of 1. So secant of 60 degrees is equal to 2. Tangent of 60 degrees is the ratio of opposite side, and opposite to 60 degrees is radical 3, to the adjacent side, which is 1. So tangent of 60 degrees is square root of 3. Once we have tangent of 60 degrees, we can set up cotangent of 60 degrees, which is a reciprocal of square root of 3, and reciprocal of radical 3 would be 1 out of radical 3. We need to rationalize this. Radical cancels out with the square, so we need another factor of radical 3 in denominator. Whatever we do in denominator, we multiply numerator by the same thing. So we get cotangent of 60 degrees is equal to 1 times radical 3. We have radical 3 in numerator out of square root of 3 to the second power in denominator. Square and a square root will cancel out, and we get cotangent of 60 degrees is equal to radical 3 out of 3. That's all.